Okay, guys, welcome to the part 2 of this walkthrough for the COMP9021 quiz 1. Okay, we have just finished the calculations for elements to keep and L1. Now we need to walk through L2 and L3. Let's start it by walking through L2. Also, what is L2? Now let's just go to the quiz document. Let's see. So what is L2? So L1 is something that actually contains duplicates. Okay, but L2 simply retain the original order, but there's no duplicate. So you can just use the L1 you already got to work out what L2 is. Yeah. So it's actually really simple. So if there is something, if one element is already in L2, yeah, stop putting more copies of that element into L2. In that way, you can avoid creating duplicates. So you have unique values that are not only elements of elements to keep, but you also retain the original order. Yes, so that's what we need to do. So now to walk through all the elements like before, we need another loop. So what is this loop? It's actually very simple, but this time I love to use A. So for A in L1, for each start from 0 element in L1 and loop through every single one of them. Yeah, so this is what you do. If if this element is not in L2, it's not already in L2, it's not already in L2, okay, that means we're gonna append this element to L2. Yes, so L2 append, and the element will be A. Okay, else we're gonna pass, but you can just ignore. Okay, let's ignore it. Okay, that's it. I think that's it. So I'm not gonna forget this time around, Okay, so calculate L2. The input will be L1. Okay, now let's select all the code and run. Okay, let's try this one again. 11, 13, 20. Okay, so L1. Now you see, we just go L1. Okay, if you're not convinced, let's try another one. Let's try this one. Yeah, we're gonna run this again. Yeah. So let's try something like 5, 10, 15. Now the L2 is also the same as the answer, so we just got it. Yeah, congratulations, guys. We just made a lot of progress. Okay, now is L3. I think it's probably the most difficult and demanding. I spent a lot of time on this, and the teacher's explanation I just couldn't understand. And so I say, okay, I'm gonna work everything out myself. This is what I did. For example, so what is L3? What does it actually mean? So L3 consisting of the longest, and in case there are more than one candidate, the leftmost longest sequence of consecutive members of L that's reduced to a set is a set of integer without gaps. So a set of integer without gaps, that is very interesting. So we have several things to consider, a lot of things to consider actually. But what I wanna do is let's just try to draw something out here. So let's just try to draw something out and see exactly what they are trying to say. Okay. So if you have a look at this list here, so the question is asking for a longest section of this list that can give you a non-stopping sequence, a sequence without gap. So within this one, yeah, you can see that I can see straight away there's a 13 and 12. But that's just very short, isn't it? So the answer is 8, 7, 10, 9, which is over here, yeah? And that is 4 elements long compared to this one. So the longest one will triumph, yeah? If we have multiple candidates of identical lengths, for example, if we have another one over here that is also 4 elements long, we take the one that is located to the left. Okay, the leftmost element is the one we want if all candidates has the same length. Okay, that is what we want to achieve, yeah. But what I take a very different approach to what other people does is that this is what my thought process is. Is for example, we just draw anything, like we started from 6, 6, 0, 4, 8, 7, 6, 4, 7, 5. So I just think using a detector approach. Let's say this is a very, very big detector that's going to examine whether this thing actually works, yeah, whether there is a sequence that, let's say, whether the whole list meet our demand, okay? So if this whole thing does not meet demand, then we need to reduce the size. Then we can reduce the size of this tip, of this detector. Reduce the size, that is just one element shorter than this list, yeah? And this list can have some degree of movement, a degree of freedom now. So it can be in this 2 position now, yeah? Or if we shorten it by 1. So now we just use this kind of approach to detect. If none of these works, we can shorten this even further. But 1 step at a time, remember. We just shorten this detector. That's this detector, one step at a time. So if none of this works, so starting from the longest detector to the shortest detector, this means that we will always get the longest list that meet our L3 requirement once it appears. Okay, now we just got this 2 freedom. Now we just shorten by another 1. So this list can have 3 degree of movement. Yeah, it can move 3 steps now, and so on and so forth. If that still does not work, we're gonna reduce this even further. Yeah. Let's just remove. We can reduce this detector even further. By now it's like can be in 4 different positions. Yeah, 4 different positions. 4 different positions. Okay, so on and so forth. So by doing this, we will eventually cover the whole thing. Okay. Eventually. I mean, in the worst case scenario is that you do not have any list that meet your demand, which means the leftmost list is gonna contain only a single element. But that I don't think that is all really going to happen anyway. So this is my thinking. By continuously reducing the length of the detector, we can somehow and the detector will always move from the left to right. So we will eventually get the leftmost list that is not only the longest, and it's also located to the leftmost position. Okay, see, now this is the series. Now when it comes to implementation, is like let's do this now. So we kind of need to define some variable, the detector length. Yeah, I talk about detector length. Yeah, detector length. But so that will be the length of the length of the list originally minus 1, because if that's equal to L, the length of L, then we have no movement at all, right? We have no movement at all. And actually, before tackling this L3, let's define another function. And I just wanna, let's say, let's call this function coherent test. Yeah, coherent test. Okay. So I wanna explain something here, which is quite important. Yeah. So what is undesirable list? What kind of trait, what's a characteristic of L3? It's like, for example, yeah, this list is over here. So it kind of so 2, 3, 4, 5. The difference between each of them, yeah, is always 1, isn't it? The difference between each of them is always 1. 1, 1, 1, right? So we kind of create a function that I don't know if you guys know. There's one thing that it can really is quite powerful. It's called numpy diff. Numpy diff. Okay. Let me just show you what I mean. For example, if I just try something here. For example, let's create a random list. Yeah. Let's create 1, 2, 3, 4, 5. Yeah, 6, 5. Okay, and let's create another list called diff list, and np.diff will output something quite powerful. Something you have. So the input parameter will be this. Now let's print diff list. Okay. So let's run this bit. Oh, sorry, I just made a mistake. Numpy, no. Okay. Select this bit. Now, people, have you seen something extraordinary? It tells you every single the gap between them. Yeah, it tells you the gap between this number. For example, 2 minus 1 is 1. So there's 6 elements here. The diff list will be only 5 elements long. Okay, that's something quite important to know. And so a desirable list, the difference between them should always be like either 0 or 1, right? So, but how can we code up all of this? How can we code up? Yeah, how can we code up? Then we need to consider something like this. I'm not sure you guys if you know there's another function that is called OR. Yeah, the OR means every single element inside the list must meet a certain condition. Otherwise, it's going to output a false. If all the conditions are met, then it's going to give you a true. So if we have a desirable sequence that meets our condition, I can use this OR function coupled with the diff list we just created earlier. We can somehow, create a Boolean logic. We can incorporate this Boolean logic into this calculate L3 function, isn't it? So let's just do, so within this coherent test, it's actually really simple. Yeah, so let's say the coherence is going to be a Boolean value. It's going to be a Boolean variable. Let's define this. And let's call OR. So let's record the numpy diff, right? Numpy diff. And remember, this difference between each of the value must be 1 or 0. So absolute value, and numpy dot diff x. The x will be a kind of the string that we want to test. Not string we want to test, the list we want to test. Okay, and this absolute value must be equal or smaller than 1, isn't it? Wait, I'm a bit confused now. And sorry, why do we have 2 diff here? Sorry, I'm a bit. I've been talking for way too long. I just so many brackets. Oh Jesus, where does this come from? Pi. Let me just check it again. So we have too many. So that's that. Okay, that should work. So that's just prove the coherence. So this coherence is gonna be a Boolean value. It's gonna test that the absolute value between each of all the list, all the difference between that list, between each of the elements inside that list must be smaller or equal to 1, and that will meet our condition, right? So we're gonna return this coherence. So remember, this is a Boolean value. Okay, this is a Boolean value. So let's just return to L3. So the detector length, right? We are on to detector length, and we also did talk about freedom of movement. So let's define an integer called freedom of movement, and then let's just start with 2. But remember that the very once we shorten the detector by 1, we immediately have 2 freedom of movement. Yeah, that should be our initial state, isn't it? So then we define another Boolean value. This will be find. Yeah, but we start with false because initially we don't even know that what is L3. So L3 is not find, so we started with false. Okay, false. And I just, for the sake of security, because I don't want to mess up L, so you probably don't really need to do this, but I just want the sense of security. So L original equals m numpy copy. I create a copy of L. Yeah, so you can mess up with all the L original, but you're not gonna mess up L. Okay. So that's what I do here. So the very first thing when we're gonna consider is when the detector is, for example here, yeah, the detector is the same as the length of the list, right? Of the list L. So what do we do here? Is let's see if the coherent test here, if the coherence test. Now we need to kind of remember that we need to sort the list in ascending order. Remember. So we can take any section and test them out. We can take any section from the L list. Yeah, we can take any list. We can do anything. And but this MP sort is gonna make sure that segment of the list L will always be ascending order, right? So we put L original here. So that must be equal to true. If that equals to true, then that's in a very unlikely circumstances. Let's just try something. Imagine. I mean, you need a luck of winning a lottery, to be honest. But imagine if the L list is exactly like this: 1, 2, 3, 4, 5, and the detector gonna be we have a starting length of that is equal to the length of the list. Then you can stop working. You can okay, I can go home now. Now I have just worked it out everything. I can just say okay, S3 is already the same as L original because it already meets my requirement. Yeah, but that's very highly unlikely. But I just want to put it just in case, because you never know what will happen. Okay, so if that. So now else is where things get really complicated. Else we need to kind of define a while loop. While loop is different from for loop. While loop is kind of to have, for example, the when the while the find is equal to false, then we still need to execute this following, right? So now we just need to implement this movement, the movement of this detector, how it becomes shorter and shorter and move from left to left, move from left to right. Okay. Okay, so all the logics here will just be laying out the structure of the detector, the working mechanism, if you want, of this detector. So for A, once again, in range, okay, what do we need to put in? A single number, right? But remember that it's called the freedom of movement. Freedom. I'll just copy this bit over here. The freedom of movement, okay? Freedom of movement. So now, for each of when the detector is of certain length, yeah? When the detector is of certain length, you move from left to right. So we need to kind of create section. Now we are now extracting sections from the original list. This L new will be L original. Do you remember how we extract certain elements from a list to make them shorter? We define the we do so by defining the range. Okay, so you're gonna start from A. For example, if this range freedom of movement equals 2, yeah? So you're gonna start from the range of 2 will give you 0 and 1. So when A equals 0, yeah? So this list will be starting from the left, right? But, yeah, I hope you guys can visualize, but I think I do think it's quite difficult to visualize this. So when the freedom of movement is of that value, you do this, you sweep the detector from the left to right, and you start from this A, and where it terminates, remember, it terminates here is actually A plus the length of the detector. Okay, I hope you guys can understand this, but I think I have already explained everything inside the diagram. That's how it works. So now we need to put this section, the section of the list that we want to test. Yeah, we want to test this. So we need to make sure they are ordered. Yeah. So actually really easy. NumPy sort again. So L new. Okay. Now we're gonna test whether the founder, we want to know the value of founder, yeah? So we're gonna invoke this coherent test function. Coherent test function. And the input will be L new ordered. Yes. So now we can know we have a value for founder, and this will be a Boolean value. This will be founder will be a Boolean value as defined earlier. So if find equals true, yeah, if find equals true, then L3 will basically be L new, which is the section of the list in its original order. Yeah. Oh, what did I do here? I delete some. Okay, now it's okay. So L3 equals L new. Okay. Then once we find, we terminate the whole process. We terminate. We do not want to make stop. We just stop looking because we start from the longest to shortest. So once we find that one, yeah, once we find L3, then L3 is definitely the longest. And as we move the detector from left to right, we can always make sure once the one we find is always located to the leftmost position. So we can stop there. But now there's another condition that actually we need to go out of the if here, go out of the for loop here, is that because each of the for loop is for a certain freedom of movement of the detector. It's for a certain detector length, isn't it? So if found equals to false, which is very unfortunate, for example, that you haven't found it, yeah, by doing the above operation, you need to find a way to shorten the detector length, in the same time increase the freedom of movement of the detector. So actually really simple. So the detector length here, right, will simply be, let's increment it by 1, yeah, and we, sorry, I made a mistake. You need to decrease the length of the detector, yeah, and for freedom of movement, we increment the value by 1, yeah. So now let's just make sure we type everything correctly. There's no typo. So now we have a list. But remember, Python, one of the worst thing about Python is that it's really difficult. The one mistake with your indentation, everything will just throw up all the wrong values. It will throw errors. So that's something I really hate about Python. But so the very last step, the very last step of L3 will be, remember, it might be an array. We need to convert the array back into a list. So we just do this here. So now everything should be ready now. Everything should be ready. And let's just put L3. L3 calculate L3. And the input should be, is L, isn't it? Okay, that's all good. So now let's just restart the moment of truth now. Moment of truth. And just wait for the restarting kernel. So now, moment of truth. Select everything. Run. Oh, guys, I made a mistake straight away. See how easy it is to make. Just double here. It's okay. Put 2 equal sign here. And make sure that, and I think I made a mistake here as well. See how easy it is to make mistake here. Let's make sure that everything is okay. Okay. Okay, and select everything, run it again. So now let's just try this one again. 11, 13, 20, yes? Now, see? This is absolutely amazing. Have a look at this. This is amazing, isn't it? Like, let's try the generated list is exactly the same. These two are exactly the same. Look, 1, 3, 8, 7, 10, 9, 7, 10, 9, 13, 8, 3, 10, 1. Everything is the same. So we have done brilliantly. Well done, guys, man. I think this is just fantastic. Well, I mean, well, you guys have achieved so much, and I hope this video is really helpful for you guys. And yeah, so I mean, please, because I know UNSW has a really strict policy of for plagiarizing. So please take some of these ideas, okay? Take some of these ideas, but do not copy, okay? Do not copy my code. Or maybe try to reinvent the wheel if you want to. I just don't want to get you guys into trouble. Please, just take an idea and do not just copy all this code. Just shut down, close all your YouTube browser now and just start from scratch. Okay, and by doing that, you will because you will always learn. You can only learn by doing. Copying other stuff will not learn. You will not learn as much. So I really want, and I don't want you guys to get into trouble. So I think I have been speaking for so long, and I hope you guys gonna have a enjoyable ride when it comes to programming. And I'm gonna see you next time. Goodbye, guys. Thank you.